Okay, so let's dive into something that's quietly changing the game for how AI connects to the real world. We're talking about the Model Context Protocol, or MCP. It sounds a bit technical, but trust me, the idea behind it is incredibly powerful and honestly pretty revolutionary. You know those incredible AI assistants we all use, like Claude and ChatGPT? They can do some amazing things, right? But for all that power, they have this one huge fundamental limitation. And here's the deal. They're basically trapped. They're stuck inside a digital walled garden. Their knowledge is completely frozen at whatever point they were trained, which means they can't see real-time info or, and this is the big one, they can't actually do anything in your other apps. They're cut off from the world where you're actually working. So to get around this, people have been building all these custom one-off connections. But think about it. Every time a new AI model comes out, you have to build a new connection for every single tool you want it to use. It creates this tangled, totally unscalable nightmare that tech folks call the N by M problem. This isolation, this walled garden, it's the biggest thing holding AI back. It's what keeps these amazing tools from being true partners in our work, and instead leaves them as just, well, really smart chatbots. So the big question is, how do we tear down those walls? Well, the solution is to just get rid of that tangled mess entirely. Instead of countless one-to-one connections, you create one universal standard. You go from that N times M chaos to just one single protocol that can connect everything. And this right here is the perfect analogy. Think of MCP as the USB-C port for AI. You know how USB-C saved us from having a dozen different chargers and cables? MCP aims to do the exact same thing, providing one universal port for any AI to connect to any tool. So how does this universal connector for AI actually work under the hood? Let's break down the three core pieces that make it all happen. It all starts with what's called the host. This is the main app you're actually using. It could be something like the Claude Desktop app or maybe an AI-powered code editor. It's the central hub. Now, inside that host, for every single thing it wants to connect to, it creates a client. You can just think of each client as being like an individual plug on a power strip, ready to connect to something specific. And of course, that plug, the client, needs a socket to go into. That's the server. The server is the program that's actually offering the tool or the data the AI needs, whether it's access to your Google Drive, your local files, or another application. So when you put it all together, it looks like this. You have one host, acting as the brain, managing all these different connections. Each connection is a clean one-to-one link between a client and a server, and the best part is they're all speaking the same language. No more custom code for every single link. Okay, so that's the theory, right? Host, client, server. It sounds neat, but what does this actually let you do? Let's walk through a real-world example to see this thing in action. All right, so picture this. You're a developer, and you ask your AI assistant, which is acting as the MCP host, a simple question about your computer. How many Docker images are on my local machine? So this whole exchange happens in 4 quick steps. Step 1 is discovery. The AI knows it can't answer this question on its own, so its MCP client looks around and discovers, hey, there's a Docker server available, and it has a tool that can list images. Perfect. Next up is invocation. The client sends a standard request to the server, basically saying, hey, can you run that list_images tool for me? Then comes the action. The server gets the message, runs the actual command on your machine to find the Docker images, and sends that info right back. And finally, the response. The AI gets that structured data back from the server and turns it into a perfectly normal, human-readable sentence. Now pay attention to what just happened. The AI didn't guess the answer or tell you how to find it. It actually went and did the work. That's the difference. This simple little interaction, it really points to a massive shift in what's possible. So let's zoom out for a second and look at why a protocol like this is such a big deal for the future of AI. Now you might be thinking, hey, this kind of sounds like RAG, Retrieval Augmented Generation, but there's a really crucial difference. RAG is all about retrieving information to make an AI's answer more accurate. MCP is about active interaction and actually taking action. It's the difference between knowing something and doing something. And the benefits here are just huge. First, you get more accurate AI because it's grounded in real live data. It's not just making stuff up. Second, you get true AI agents that can automate real tasks. And for developers, it finally solves that messy integration problem by creating a true plug-and-play ecosystem. And this is the really cool part. This isn't just some theory. Big players are already building on it. There are already MCP servers out there for Google Drive, Slack, GitHub, Microsoft Learn, you name it. A whole ecosystem of connectors is already popping up for everything from business tools to coding. And that's what's so powerful. This unlocks intelligent automation for pretty much everyone, not just developers. Think about a technical writer. They could ask their AI to automatically pull the latest updates from 5 different systems and draft the release notes, all from a single prompt. When you really think about it, this is about building a future where our AI assistants aren't just stuck in a chat window. They're seamlessly woven into our digital lives, ready to jump in and help with any task we throw at them. And as the CTO of Block, Dhanji Prasanna, puts it so well, this is a foundational shift. It's about building the bridges that finally connect AI to real-world applications in a way that's open and collaborative for everyone. So, a protocol like this doesn't just make today's AI a little better. It fundamentally changes what AI can be. It transforms it into a true co-pilot that's integrated into everything we do. Which really leaves us with just one big, exciting question. Now that AI can connect to anything, what are we going to build with it?